It says find the fifth term and the nth term of the geometric sequence whose initial term, a, or I call it a sub 1, and common ratio are given. Now remember, the nth term is the general formula. A sub n is equal to a sub 1 times r to the n minus 1. So the nth term would be a sub n is a sub 1, which is negative 2, times r, which is 4 to the n minus 1. So there's your nth term. So essentially what that is your sequence generator. So now I can find anything in the position that we're looking for. I want the 8th term. That's a sub 8, which is negative 2 times 4 to the 8 minus 1, which is negative 2 times 4 to the 7th, and negative 2 times 4 to the 7th, and I had to move to my calculator, new one, different one, because mine needs charged. Negative 2 times 4 to the 7th is negative 32,768. Now what you're noticing is, even at term 8, these numbers are getting really big. That's the hallmark of a geometric sequence. Yes?
It's fifth term, not eighth.
What?
It's fifth.
Just the fifth.
Fifth term.
Oh, I said 8th. Oh, okay. Same thing. What am I going to do? Change the 8 to a what? 5. Yeah. I don't know why 8 sounded good to me. It's going to be a small or big number. So if we're looking at the 5th term, and what I should have done is just change that to the 8th in your packet, and I wouldn't have to do this. This would be a 5 minus 1, which is a 6. And now I'm going to recall and change that to a
4.
5 minus
5 minus 1.
1.
Oh, picky. 4, which is, oh, it's not too bad. It's kind of bad when you can't find your watch in your own house. You know it's there. Looked every place I could have laid it down. But fortunately, we got a clock back there. Okay, 5th term. With the 8th term, do the same thing. So here we go. We want to find the nth term, so that a sub n is a sub 1 r to the n minus 1, so that a sub n is a sub 1, which is 1, r to the n minus 1. So there's your nth term. And of course, you don't have to include the 1 if you don't want to, because 1 times anything is just itself. I want the 5th, let's get this right this time, a sub 5 equals 1/3 to the 5 minus 1, which is 1/3 to the 4th, which is 1/81. Small number. What I want you to kind of see is that when r is a whole number, or let's say greater than 1, that the numbers get big. If with this thing being a 7, it was 32,000 negative. So they just get bigger and bigger and bigger and bigger and bigger. And when r is a number between 0 and 1, it's going to get smaller. Now that should make sense if we remember anything about the exponential function, because that's what this is. The only difference is, instead of having solid lines, there's a series of dots. That's all it is. Because the domain is the set of counting numbers. So that if I wanted to graph, say, y equals, and I'm just going to go 4 to the x because that's going to make life a little bit easier. What would this guy look like? Well, if x equals 0, y equals 1. If x equals 1, y equals 4. If x equals minus 1, y equals 1/4. And as a function, it looks like this. So that says as x gets bigger, y is going to get bigger. And as if x gets smaller, y is going to get smaller. So we're actually, if I'm looking at now what we're dealing with, this would be a sub n is -2, 4 times 4 to the n minus 1. If n were an x, so that would be y equal, this would be, reflect the x-axis. This would be vertical stretch factor of 2. This would be right 1. So if it's right 1, what I am dealing with, if n equals 1, that would be 0, -2. And he is going to continue going down like that, like with a series of dots. So that says as s gets bigger, y gets bigger in the negative world. Y gets bigger in the negative world. Now, if I take a look at this guy, this is 1/3 to the n minus 1. So if I looked at just y equals 1/3 to the x power, what might he look like? Well, 1/3 to the x power, if x equals 0, y equal 1. If x equals -1, y equals 3. If x equals 1, y equals 1/3. This is the guy that looks like this. So that if x gets bigger, y gets what? Smaller. The only difference is I'm looking at a to the n equals 1/3 to the n minus 1. At 1, I get 1/3 to the 0, which is 1. And then he's going to continue down like that, a series of dots. It kind of follows this right here. So as x gets bigger, y gets smaller. So if r is between 0 and 1, y is going to decrease. And if r is 1 or bigger, y is going to increase, either positive or negative, depending upon the sign. This is the exponential function. The only difference is instead of having a solid line, it's got a series of dots. Because the only values you can put in are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. Almost like data, because you didn't do data, so. So here we go. Find the indicative term of each geometric sequence. I want the 8th term. So a sub n is a1 r to the n minus 1. Well, n is 8. a1 is 1. What's r? How do I get from here to here? Multiply by 3, so r is 3. So I can say that a sub 8 equals a sub 1 times r, which is 3 to the n minus 1, and n is 8, or a sub 8 equals 3 to the 7, and 3 to the 7 is 2187. Find the 10th term of, well, let's see, well, we know, again, a sub n is a1r to the n minus 1. a1 is negative 1. N is 10. And r is negative 2. So, a sub 10 is a sub 1 times r to the 10 minus 1, which is minus 1 times negative 2 to the 9th. So, minus 1 times negative 2 to the 9th is 512. Not so bad. You're going to find it's going to be using these formulas over and over and over again, which is why I write them down each time, because then I know what I need to use when I go to do the problem.